All right, let's go ahead and use the quotient rule in some different examples. So let's go back and remember what the quotient rule is. Okay, if I want to write it very succinctly in this kind of notation, if I want to take the derivative of a quotient of function, so the derivative of f divided by g, or f of x divided by g of x, I get this funny looking quotient. It is going to be the derivative of f times the function g. So g I'm leaving alone here. So f prime times g minus f times g prime. So the function f times the derivative of the function g, all divided by the square of function g. So let's do a couple examples. Okay, let's keep this one in mind. So let's find the derivative of b of x, which is x cubed minus x plus 2 all over x. Okay, this should look familiar to you. You should have done this in class already. Make sure that you know how to, number one, know what the derivative in class was. So look that up, because in class we did this another way. But also try it on your own using the quotient rule before I do it. So go ahead and press pause now, because now I'm going to do it. So here I have two functions and I'm finding their quotient. The numerator is the function f and the denominator is the function g. So if I want to take the derivative of b of x, what's going to happen is I'm going to take the derivative of f. So I want to take the derivative of x cubed minus x plus 2, that derivative, times g, what I get when I just leave g alone, minus, now I'm going to take f, x cubed minus x plus 2, I'm going to leave it alone, times the derivative of g, so times the derivative of x, all divided by the denominator squared. So the denominator here is x, so that's what I'm squaring. So let's go ahead now and take these derivatives. This was my intermediate step. So now I take the derivatives. The derivative of x cubed minus x plus 2 is 3x squared minus 1. So I get 3x squared minus 1 times x minus, now the derivative of x is just 1. So I'm subtracting x cubed minus x plus 2. If you ask me why I'm still putting that in parentheses, it's because I have this minus sign here, and I'm subtracting all of x cubed minus x plus 2, and so I don't want to forget about that. Okay, and then of course all over x squared. Now in class, this is not the answer we came up with, but of course right now this is very unsimplified. So in class, when we came up with this, we came up with 2x squared minus 2 over x squared. So let's see if we can come up with that same answer. So let's go ahead and simplify the numerator. We get 2x cubed minus x cubed minus x plus 2 all over x squared. So let's see, let's keep going at the bottom. 3x cubed minus x cubed is 2x cubed. I have a minus x. Oh, look, I made a sign error. I made a sign error after I just said be careful. This should be a plus x, and that should be a minus 2, because I was supposed to distribute the negative. So let me go back and fix that. It should be a plus x and a minus 2 all over x squared. There we go, that's better. So now we get 2x cubed again. Now minus x and plus x cancel, and minus 2 all over x squared. That's looking a lot better. So let's try to make it look like it did in class. We had it as two separate fractions instead of all together. So this is the same as 2x cubed over x squared minus 2 over x squared or in other words 2x minus 2x to the negative 2, which is exactly what we did when we rewrote this quotient in a different way in order to just use the sum principle and the power rule. Okay, now we're going to do another example. Let's differentiate v of t. Now we're going to take the derivative with respect to t. Now where v of t is this quotient, 3 to the t minus 2t to the fourth plus the square root of t, all over t squared minus 7. So v of t is a quotient of functions. Our numerator function f is 3 to the t minus 2t to the fourth plus square root of t. And our denominator is t squared minus 7. So when we're finding the derivative, we want to first find the derivative of the numerator. So 3 to the t minus 2t to the fourth plus the square root of t. That's what we find the derivative of first. And then we multiply by the denominator, t squared minus 7. So I haven't done it anymore. I haven't done it yet. This is just my intermediate step telling me what to do. Minus, well, I'm going to leave the numerator alone, 3 to the t minus 2t to the fourth plus the square root of t. Now times the derivative of t squared minus 7. Oh, I'm running out of room. I need to take the derivative of that. And then I divide everything by the denominator squared, so t squared minus 7 squared. Okay, so let me go ahead and take those derivatives now. So the first thing I need to do is in the numerator find the derivative of f. So to find the derivative of f, I use my exponential rule, so natural log of 3 times 3 to the t minus 8t cubed plus, now I need to take the derivative of square root of t. Remember, square root of t is the same as t to the 1/2 power, so I use my power rule. 1/2 t to the 1/2 minus 1, or negative 1/2. Okay, all of that is the derivative of the numerator. So times t squared minus 7. Now, minus 3 to the t minus 2t to the fourth plus square root of t times the derivative of t squared minus 7, which is 2t. All of that divided by t squared minus 7 squared. No derivatives being taken in the denominator here. Okay. All of that is the derivative of v of t. It's very gross and complicated, but you do not need to simplify anymore. Notice this was a case where we couldn't have simplified it using division if we had wanted to only use the sum rules like we could have in the first example. So in the next video, we're going to mix both quotient rule and the product rule.